Why do some skyscrapers sway, and how do we stop it? At over 1,000 feet in the air, even the strongest towers move with the wind. The higher you go, the more the invisible forces of gravity, wind, and even the Earth's rotation start to fight against you. I remember working on a tower design early in my career where we had to test how the building would perform in hurricane-force winds. We built scaled models, placed them in wind tunnels, and watched as invisible air currents shaped everything from the corners to the crown. What struck me the most was how something as intangible as wind could decide whether a tower stands gracefully or fails entirely. Most people think skyscrapers are just taller versions of regular buildings, but once you reach the scale of supertalls, the rules change. These aren't just structures, they're feats of physics. The difference between stability and disaster can come down to hidden systems most people never see. Take tuned mass dampers. Imagine a giant 700-ton pendulum suspended near the top of a tower, quietly swinging back and forth. Its job is simple. When wind pushes the building one way, the damper pushes back. You'll never see it while you sip a cocktail on the 90th floor, but it's working every second to keep you comfortable. Or think about the foundations. In New York, some towers extend over 100 feet underground, anchored into bedrock. The steel and concrete that rise above the skyline depend entirely on what happens below ground. And then there's aerodynamics. Towers are shaped, not just styled. Round corners, setbacks, and sculpted tops don't just look elegant, they break up the wind vortices that could tear the building apart. Every curve has a purpose. Designing a supertall is like designing a vertical city. It's not just about elevators or office floors, it's about systems that have to perform under conditions few people ever experience. Water pressure at the top floors can require pumps more powerful than some municipal systems. Elevators aren't just vertical, they're zoned, stacked, and sometimes even diagonal to keep people moving efficiently. And while glass facades might seem like simple skins, they're engineered to handle incredible wind pressures while insulating against the heat and cold. What looks like elegance is always hiding performance. The result is a building that shouldn't stand but does. A structure that bends with the wind without breaking, that turns invisible forces into opportunities for design. That's the secret of super tall towers. They're not just taller buildings, they're the most public experiments in engineering, monuments to what happens when imagination meets physics. And every time they touch the sky, they remind us how far design can push the limits of possibility.